First of all, what I'm going to do is I'm going to post this. This is a story map. This whole presentation I've been giving so far, it's actually a story map. So I'm going to go to the chat box. I'm going to paste it in here. The reason why is because, as you can see from the size of my little scroll bar over here on the right side, I'm only showing you a tiny bit of that story map. I wanted to pack it with other things that you could look at, for example, in the coming weeks. And feel free to email me or drop me a note. Joseph, I took a look at the 3D capabilities in that you've got linked in the story map. And I'll say, awesome, keep on moving forward. That's great. So just to give you a sense of where this technology is going, I want to give you a couple of short demos. One of them is a trend that I can see that we're in the midst of. We're in the midst of it, but we're also on the cutting edge of it with geospatial. So picture your typical infrastructure that's under, I know this is near and dear to your engineering hearts, underground. In the past, we've had, some CAD drawings, computer-aided drafting and design, and they've been sort of adequate for certain places, but in other cases, you've got hundreds of years of cabling and water lines and stuff like that. What we've got at the moment is we've got ESRI, our organization, we have business partners. One of them is called RGIS, so Augmented Reality Gis. The point is, if we go to that video, it's RGIS, and inside there, you've got a tool. It's an app on your phone, and if you create an editable feature service inside ArcGIS Online, for example, or ArcGIS Pro, both of which you have at your fingertips at Howard, you can, with the app, walk through that location, as I showed you here a moment ago, with the phone app and the editable feature service, see what's underground, perhaps avoiding the need for digging and consequently spending a lot of time, money, and resources. So that's just an example of one of the trends that Clinton and I and others here at ESRI really get excited about, and that is augmented reality, the Internet of Things, 3D mapping, and other things that we'll talk about here in a moment. Let me just lay out a couple of other things, and then I'm going to close with a couple of short demos. This set of tools that I'm talking about right now, this isn't going to be the same presentation that I would give in the spring or even a month from now. GIS, Geographic Information Systems, just like tools that you all use, are continually evolving. That's actually good, because when you graduate, you'll be equipped using these tools at Howard to say, you know what, this is the most important tool, and I understand how to use some of these tools. I might not understand all of it, but I can use some of it to make not only understanding current operations, but to plan for and enable change. That's the idea behind Geographic Information Systems. It allows students and graduates to be change agents in their community. And that's pretty exciting. So for example, we talked about a couple of these trends so far. The merging between CAD, BIM, and AEC and Geographic Information Systems, interior versus exterior space mapping, that's pretty exciting. Machine learning, artificial intelligence, that's changing the face of GIS. I don't have time to get into those right now. I mentioned the Internet of Things with these live feeds from weather and stream gauging stations and citizen science input. Let me go into actually about 3 short examples, and then we'll open up for questions. One of them is to give you an illustration of what we did in the past with Geographic Information Systems on a serious topic like accidents. Okay, in the past, what we've done is we've created maps like this, and this is just in ArcGIS Online. It's a 2D map, as you can see, of certain traffic accidents in a community. Serious issue, and I know I've been impacted by this in my own family. Perhaps you have as well, with loved ones, friends involved in crashes of various kinds. So it's a serious issue, right, affecting all of our communities. This is really hard to understand, right? We've got all kinds of points, and they're all mapped the same way. Now, what we're doing with Geographic Information Systems is we're creating these, for example, hexagons for data, so we can aggregate the data and then run it through spatial statistics where we can see hotspots of accidents. Now, you know as well as I do, every project has got a finite staff, budget, time constraints. So if you were assigned, hey, you got to address these accidents in a community, where are you going to focus your effort on? So if we move it into the 3D environment, you've got these 3D extrusions, and then you could see, okay, which areas are in these consecutive hotspots, and that's where I'm going to focus my effort on, because they've been statistically high for accidents for a period of time. And that's where I'm going to focus. And if I can reduce the accidents there, that's going to go a long way to making my community safer. So the point is, this is visualizing things in new ways so that we can make wiser decisions. That's the whole point of GIS. Yes, we love the technology. Yes, it's a meaningful career. You're going to be more marketable having GIS on your tool belt as an engineer or a hydrologist. But most importantly, you are helping our communities and our world become safer, more sustainable, healthier, and happier. And that's really the goal. One more demo, if you don't mind. I've got in this story map some articles that you can read about water and a student project and other things that I just don't have time to go into. But I want to show you a couple of just one demo. How about a flood impact analysis? Oh, I love this. Again, because yeah, the tools are great and the visualizations are good, but think about the impact that these could make. So this is inside ArcGIS Pro, and then, which is a tool that you have at Howard, and then you can serve that out to an online web mapping application like this, a 3D set of tools. So what we did here was we input a couple of different layers. We've got the 3D buildings from Microsoft, basically, and they got those from many municipalities, their assessors, departments, and others. So you've got 3D buildings extruded, and then you've got the flood 100 and 500-year flood potential for a community. And then we're going to look at, okay, based on that, which areas are going to be potentially affected by a 100 or a 500 year. Now, digging deeper into the data, like we were talking about earlier, I know you probably have experienced some weather events in the past in your lifetimes. We had a big flood in Colorado back in 2013 that you may have heard about way back when you were in I don't know, high school maybe. But the point is, the 100 and 500 year, not so good, because we had way exceeding the 500. So even those flood models are not maybe so adequate. And so one of the things that we want you to think about is maybe that's not really a good term for these things, because we've exceeded the 500 year in just a couple of times here in my own community. And so which areas would be potentially impacted by even a higher flood stage than what this particular data set shows? And then therefore, what's the assessed value in each one of those properties? How many people live in the dorm or in the hospital or in the nursing home or wherever is potentially impacted by these 100 and 500 year perimeters? So this is just an example of using GIS to help us make smarter decisions. Yes, it's okay to look at a table of data, as you saw here. Here's a demographics for Washington, D.C. as maybe my final demo. So we look at median age. Okay, why is the median age different in different neighborhoods in DC? Well, if we looked at Howard University and we said, oh, I'm going to drop a point on there. Okay, so now I've got a point on there, and if I click in here, I've got a whole boatload of data, and I can see that the median age in your neighborhood is according to this data set, 2018. So it's a couple years old, but it's 19. I was 19 once, way back in the Stone Age. Anyway, the point is, this confirms my hypothesis, right? You've got a university campus, you've got a lot of undergraduates living in and around campus. So it makes sense that the median age is less. If you went just to the northeast of you all, right, you've got a much older population, as well as in other areas of DC. So why is that? Remember, what's where, why is it there, and why should we care? So we have different median ages of population depending on neighborhoods. And we want to dig into, okay, so I want to look at marketing a product or a service, or I want to cite a skateboard park, let's say. I don't know a whole lot of 90-year-olds that go skateboarding. Maybe there are, but maybe I want my skateboard park to be in a place where there's a lot of, younger people. I know there's a lot of middle-aged people like me skateboarding, not me personally, but anyway, the point is you can use data like this. And sure, it's intriguing to look at this whole database, but looking at it on the map like we were doing before, or, in closing, we have a whole racial equity, for example. That's one of the issues of our times, right? And so we've got data, and maps that you can pull up, again, so that you're a change agent in your community. The whole point, and there's no shortage of stuff that we could dig into, that you can dig into in the future here. The point is, you're using data to make decisions. So here's one of the resources that is associated with that. It's called the policy maps. So I say, hey, I want to look at the policy maps, and then percentage of population under 18 in households with no computer. That's kind of a key issue of our time, right? If we're forcing kids to learn online and they don't have a computer, that's kind of a problem, right? So we look at these patterns and relationships and trends, and we can symbolize things. In this case, we've got percentage of population in this color, ranging from this sort of tan to a darker color. And then we also have the box, the square, that is the actual total population. So if we look at, if it's dark and it's a big box, that's not so good, okay? So we've got ways of mapping not just one variable, but more than one variable. Unfortunately, we're out of time, but take a look at this policy maps zone and the hydrology resources that I've got in this story map here. And this whole thing is, why should hydrologists and engineers care about GIS? You've got my contact information in there. And again, we just touched on, I've got some other hydro and engineering demos in there that you might be interested in. I would encourage you to check those out. But for right now, does anybody have any questions or comments? Or it's a real pleasure to be with all of you today. I just salute that your professor and you all are interested in these topics, because again, you know, this is just so relevant to our times, right? Natural hazards, racial inequities. I mean, we've got all kinds of issues that we need to solve, and we need to solve them now. And these tools allow you to visualize and start solving those things. Clinton, hi. Do you want to say a few words to these fine Howard University students?
Hey, everybody. I'm Clinton Johnson. As you know, I lead Esri's Racial Equity Initiative, and I'm a solution architect at Esri, with 20 years plus in GIS across state and local government, now more formally in the IT space, working at Esri. And I'm really excited to get to engage with students at Howard and other schools, particularly HBCUs. And I'm hoping you all are getting more and more interested, not just in STEM, but in GIS specifically. And I would love to hear more from the very, very quiet students on this call today.
Thanks, Clinton. Clinton doesn't look like he's got 20 years of experience. I, on the other hand, am like looking at old photographs of myself going, oh my gosh, Joseph. But Clinton's very well preserved, and just an example of, you know, we've got all kinds of needs out there, right, folks? And these GIS tools, they allow us to look at things in different scales. And also the thing that Clinton and I are excited about is getting a wider diversity of people in GIS. You know, traditionally, like I said, it was geographers and environmental scientists, and that was good. But if we can get the engineers, the economists, and the social workers, and hydrologists, and others, we're going to have a much more a robust set of tools and data and expertise to solve these problems. So, yeah, thanks, Clinton. Awesome to see you.
Oh, no problem. It's just it's so wild. Like, why is everybody so quiet on the call?
I have a question.
Pick up. Okay. Oh, good. Excellent. Go ahead.
Morning. Thank you for your presentation, by the way. I like the energy. It was great.
Thank you.
What is the most fascinating use of GIS that you have seen? Both of you, so Clinton and Joseph. What's the thing that you cite when it was used and you're like, wow, this is amazing kind of thing?
I don't know. I think some of the things that just like I got inspired by some really fundamental things. I'm from Philadelphia, and I knew that there was this thing called redlining. But once I started working in local government, and I'm sitting in front of maps all the time, and I could really see how geography could be used to sort of orchestrate oppression. That was interesting. It was intriguing, and it gave me you know, a perspective towards, well, how we can use it to change. But then there were also like some really interesting opportunities to use GIS that I've seen sprinkled around, like things that have space that we don't necessarily think of. In the 90s, people were looking at how to use, beginning to look at how to use GIS to map to map solar system and galaxies, and people continue to do that. People were looking at using GIS to the GIS tools to look at how blood and other fluids move through the human body, right? So like just thinking about how location operates on such big and large scales and how it impacts, the world we live in. And then after like 9/11, playing video games and seeing GIS being incorporated into building really realistic and robust landscapes in video games, the same kind of technology being used by people to plan around how to deal with the impact and the fallout from 9/11. Just like the wide range of uses just across the board have just always inspired me.
Yeah, I'd have to say that's a great question. Clinton talks about, I mean, his answer to me, it's the perfect example of the scales that you can look at. I mean, he talked about the solar system all the way to the individual human body. When I was at the USGS, I actually worked with the folks in our Flagstaff office. They were doing the interplanetary mapping. So they made maps of the moon and Io and Ganymede, and it was just fascinating stuff. But then, the local, extremely local, like your own body. Our GIS is kind of like our president of ESRI, Jack Dangerman. He a lot of times calls GIS the nervous system of the planet. You know how your own body's got this nervous system and it regulates all your vital organs, right? So without it, we wouldn't be here. And GIS, like this example here with this wastewater treatment plant, it's powering the electricity and that's powering your computer right now. It enabled, that food to be delivered that you had yesterday, to the grocery store, the supply chain management on your phone. How did that phone of yours get assembled? It's sort of like an elevator. It's behind the scenes. You just, you go in an elevator and you punch a bunch of buttons and you just expect it to work. That's kind of how GIS is. It's actually fundamental to the metro in DC, how the metro operates, all the way up to, global studies. So certainly, back on the original question, though, certainly that JHU coronavirus dashboard is the most popular web mapping application ever created. And again, the reason is because people wanted that information. And so if we would have been, having this conversation with you folks at Howard, 5-10 years ago, it would have been desktop only GIS. We wouldn't have been able to share much at all with each other and collaborate on things. But now with this sort of thing, having the exterior and the interior spaces being able to be mapped and then shared and then used to make a smarter decision, that's just, the cloud-based GIS has just opened up numerous worlds. And I know Clinton was back, he started back in the days of when it was really clunky and hard to share and actually to create this. We used to rejoice when our points on the ground that we collected in the field, like in a neighborhood, would overlay on top of our base maps. We would be like, oh, this is so awesome. And now, you students are like, well, of course they would match. Why wouldn't they overlay? Well, it was really a pain in the past. So yeah, there's some exciting times for sure ahead for all of you students in GIS, most certainly.
I have experience in GIS, but it's Saga GIS and a bit of QGIS at times, and this hard focus on ArcGIS. So I was wondering if there's like a fundamental difference across all three, or is it like math, one or two, you can do all?
Clinton, I'll let you go first.
No, honestly, I don't have a lot of experience with the other GIS platforms. I would imagine, though, that there should be capacity to create and edit features and to map and analyze, those features and data and to access data. So in terms of like making a transition, if maybe that's behind what you're saying, I would say very likely what's happening is people are looking at, when these other tools are built, they actually are looking at Esri first in a lot of cases and trying to model what exists in Esri and make that accessible in limited fashion, right? Like bits and pieces of it. So you'll probably have an easy time finding, comfort and homes in ArcGIS Online, either from some concepts that you can recall from those other platforms, or just from being now everybody's sort of a casual user of GIS whenever you are, using your phone to order food or, you know, whatever it might be. So
I agree with Clinton. If you understand, okay, you're going to buffer each one of these wastewater treatment facilities by 100 meters. If you understand that in QGIS, the buffering, it's a proximity tool. It works the same in ArcGIS. So it's the concepts that it's actually going to be valuable. So all that work that you've done in other GIS platforms, that definitely will be valuable going forward. I would say that the ArcGIS is the advantage of that is that it actually is a platform. So you've got the field tools, like I was showing you with Survey 123 with my walkability survey, and you've got these 3D tools and links to our statistics package and to Python and JavaScript and other coding libraries. You've got 2D and 3D capabilities in analytics. So it does have some advantages, but certainly all that work that you've done in other tools, that's going to be valuable going forward for sure.
Okay, thank you.
Hello, I have a question. Is there anything that ArcGIS doesn't do that you guys would like to see it do in the future, or any way that you think it could be updated a little bit more?
Ooh, good question. Yeah, we actually have a ideas portal, by the way, that you can actually go to ideas.esri.com, or maybe it's ideas.arcgis.com, Clinton. I can't remember which one, but anyway, there's just search for Esri ideas. You can submit ideas that, hey, you're missing a tool here. We need to have that tool. So we, as Esri employees, and also you as folks in outside organizations, can actually submit ideas to there. So yes, absolutely. GIS is not perfect. It's been criticized in the past for being a bit too positivistic and quantitative. And now with story maps and some ways that you can kind of incorporate some qualitative data, it's at least kind of moving toward a wider encompassing of a variety of different kinds of data. But in the past, it was a bit too positivistic in its structure. Yeah, that's changing, but yes, there are lots of things that we wish it would do a little bit easier. The point, though, I think is it is evolving, and every time it does update, which is quarterly. So, kind of keep your knees bent. That tool, that button might not be in that location tomorrow or next year in the same way it is right now, but no worries. You know that, okay, I've got to figure out a 100-meter buffer of this structure, and I'm going to look for something to do with buffering or proximity, and I'll be able to find it. And there are plenty of tutorials, books, massive open online courses that you can use to move forward, which I probably should mention here at the end here. Yeah, great question.
I had a question on so you know how with GIS you can have a map that's online in your account, and you have the option to open it in the desktop app. Is there any way that when you open it in the desktop map and you make edits, it will also automatically update the online map without having to create a web map?
You can edit your web maps if it's editable in Pro, and if your data, if I'm understanding you correctly, is streaming down, let's say, okay, just to back up for just a moment. Remember, I was using ArcGIS Online here with you all a bit ago, and you've got analysis tools in here. There
Yes.
are about 45 analytical tools inside ArcGIS Online. So running in a web browser, no installation required, all on the cloud. Okay, so you got about 45 tools. In ArcGIS Pro, you've got about 1,100 tools. So a lot more capability. And Clinton and I are all about, hey, choose the most appropriate tool for the job. If these work for you, you don't need to go into Pro. But Pro, especially for you engineering and hydrology students, it's going to give you a lot more capability. And so you're probably going to need to tap into it here soon. When you open in Pro and you've got some editable features from ArcGIS Online streaming in, if it's an editable feature service and you're the author, you can update that in Pro and it'll automatically update online. Now there's
Okay.
a variety of different kinds of web maps and apps. So if it's a map and not a feature layer, I know this kind of gets into the geeky details, but then you won't be able to update it. Or if it's a map package, you'd have to republish it in ArcGIS Online. But if it's an editable layer in ArcGIS Online and you have it streamed into Pro and you edit it there, it will update in your cloud-based environment.
Okay, Thank you. And I had a second question. How can we, or where can we find out more information about buffering that you were talking about, buffering and filtering in ArcPro?
There is a learn.arcgis.com set of lessons. Now you're going to get a lot of good immersion there at Howard U. But if you want to dig deeper on your own, we've got several hundred lessons on how to build a story map, how to build that survey that Joseph was showing earlier, how to do analysis like with buffering and overlays and enrichment and other tools that we have in there. So we've got lessons on all of that. We also have, as you would expect, like when you're fixing your sink at home, right? You've got Bob's sink videos, right? And so here you've got tons of videos as well on how to actually take an unregistered historical sandbar map of Washington, D.C. and get that registered into your GIS so you can look at changes over space and time, that type of thing. So there's no shortage of resources to move forward. But I would look at, in your case, I would look at the ArcGIS Pro. I know this sounds really boring and dry, but the help documentation is actually really good. So if you go to the Pro help documentation, there's graphics in there. Sometimes there's links to videos. And I would say in your case, look up the proximity tools and it'll give you, okay, when to use it, what are the options of that sort of thing. So here's the 3D proximity tool set. There's also a 2D proximity tool set. It's maintained so that, it's always current as the current version of ArcGIS Pro. So anyway, I would start there if you have specific questions about tools, but I wanted to mention the Learn Lesson Library too. I know we're kind of running out of time here, but sorry for the long-winded answer.
No, thanks for your question. I have to hop really soon, but I wanted to mention something real quick before I left. So I also founded and lead an organization called North Star. We call it the North Star of GIS, and we're focused on increasing representation, belonging, and inclusion for people of African descent in GIS. So, as a part of our mission, we're looking to get more people like you all interested in GIS and also get you connected with folks for mentoring and opportunities for scholarships and such. So if you're interested in any of that, I'll drop some links in the chat. We started to create sort of an atlas of where we all are across the planet in GIS. So I dropped a link to that. So maybe add yourself to the atlas, get connected to some folks who can help answer some of these questions whenever they come up, get connected to a broader network of people of African descent working in and around GIS across the globe. We can get you connected to Black geographers in UK and African women in GIS and groups like Blacks in GIS that's US based. We're just trying to build a global connected community of people who look like us who are interested in this work. Like I said, get connected. You'll hear more from us in our group, and we'll let you know about opportunities as they arise.
Thanks, Clinton. Awesome. Hey, folks, I know we've got to disperse and you probably have other classes, but thanks, Dr. Shalaby and you students for wanting to dig deeper into this. We appreciate it. Thanks, Clinton, for being here as well.
Yeah, thank you so much, Dr. Kursky and Dr. Johnson. We really appreciate having you here, and I'm sure this has piqued our students' interest and some excellent questions, actually. I'm very impressed. So thank you so much. And thank you for sharing all the links and for recording this for us. So that way students can go back and, watch it. I'll post this on Blackboard and make it available also to other professors in our department. So thank you so much. We really greatly appreciate it.
Wait,
Thank you.
Can I ask a quick question before we wrap up? The lessons page, does it have, let us say I am brand new to GIS. Can it walk me through from what are the files?
Yes. Yep.
Okay.
Yeah. In here, there is a zone where you go to a path. So if you go to path, and I can jot me an email as well. This is an introduction, for example, to policy mapping, the policy maps that I showed earlier. So paths are, watch this video, go to this lesson, then do this. It's as the name implies, it kind of guides you along with whatever you're interested in learning about. So that's called a learn path. And I can help you further with that. But yes, absolutely. we really encourage you to, start dipping toes into the shallow end of the swimming pool, and give yourself space and time to kind of get the feel for this, as well as the merging of CAD, CAM, BIM, and GIS.
Okay, thank you.
All right, folks.
Thank you so much.
All
Okay,
best
I
wishes.
guess you probably would email me the link or for the recording.
Yep.
Okay, excellent, excellent. Once again, thank you so much, Joseph. We really appreciate it. And Clinton.
Oh, it's our pleasure.
Thank you.
Keep in touch. Let us know how we can help. Take care.
Thank you. Thank you.